Hey Amit, hey ML.
Hello.
Hey Julia.
Hey
Good
everyone.
morning.
Should we go ahead and get started, VJ?
I think we can. I was just waiting on if Andy would join. I know there were a couple of tests that he was going to run last week. But yeah, let's start and then I think if he joins, then we can talk about that. Yeah. Um, let's go ahead. So I think ML, maybe we'll start with you. Any updates on your end?
Uh, Not too much update for today. We're still in discussion with our dust cap supplier regarding the change of color. So I don't have a date yet. I will come back with a date for when we expect to be able to change. But because of these discussions, I can't really give a date at this moment. But I think for Monday next week, I think I will have some more clarity for that. And regarding the KOC study, uh, the results has been uploaded since last time, but I'm still working on trying to find some time to make that summary as well. So that's on me. Uh, so not too much update, but work in progress.
Yeah,
Okay.
Emil, I
Um,
think in answer to your question that you emailed me about too, well, yeah, I think the KOZ, the keep out zone analysis, if you can kind of share like high level summary of the uploaded data, that would be great. And then in answer to your question about like if we would also be updating the like IT the ORV3 IT gear design guide. I don't think we're not gonna update that spec. But what we can do is just like in our summary report for the EPDM like investigations, we'll have a section on the keep out zone and we can just like call out um like a high level summary, like, um uh if the same keep out zone still holds, then we can just state that. Or if there's like significant reduction in some area, we can just have a line on that. I think in general, we're trying to keep the keep all like the documentation, kind of try to keep it low lift and to this like summary report.
Okay, yeah, that makes sense. Yeah, so I'll continue to work on like a high level summary.
And I guess ML, just for the team here, based on the KOZ study, like overall, would you say that results were as expected, or any surprises or issues?
I would say as expected. I didn't see. I mean, we have changed the length of the hose and the routing or the position of the guide, which of course affects how much the tubing is protruding. But overall, I wouldn't say anything unexpected that we saw.
Okay. All right. Anything else, ML, on your side?
No, I think that's it for me.
Okay. Thank you. Hey, Amit, thanks for joining. Any updates on your end?
No, Vijay, not really. I mean, the testing has been already completed from our side. We shared all the details. And I
Right.
see that the caps color change Pantone 2028 or equivalent, I mean, nearer shade is what we discussed. We have adjusted our internal records and, we are working with the supplier to see how we can make this change. So I think by end of next week, I think we will be able to give a firm date, I mean, on the feasibility and when we can make that change happen.
Okay. So basically, so what I'm hearing is no issues with the color change. I think it's basically by end of next week you would provide us a timeline on when it can be brought into the production.
Yes.
Okay. Hmm. Okay. All right. Thanks. All right. And then I think Andy, any updates on your side?
We were not able to perform the testing for the kind of a retry of the combinations that had a connection difficulty with the Parker hose. I've talked a little bit to our team here, and I'm just really having difficulty figuring out a time I can get into the lab for this testing. Just with equipment
Right.
utilization for the lab. I mean, there's basically no time in our schedule for the next month. I'm trying to figure out a time if I could do it like after hours or something. So I'm still trying to figure that out. I'm hoping I can do it soon. But that's my update.
Okay. And once you have the time, you mentioned that it's going to be like roughly maybe a couple of days to run the test.
Yeah, I think, right.
Okay. Okay.
I
guess
would basically, I would just be concentrating on those high-speed dry connects, and then if I'm still seeing a problem, trying at a lower speed.
Okay.
Oh.
Okay. I guess so, Julia, what I'm thinking is maybe, I mean, I'm guessing, Andy, if you can check with your team and come back to us with, the date that is feasible. Especially if there's any changes to the schedule on others testing that's going on, or if there is a window that shows up, please let us know. Yeah, but from your perspective, would you say that it's a low risk in terms of um, not testing? How would you categorize it from a risk perspective?
Uh, well, it's, you know,
I don't.
connecting and disconnecting dry at this high of a speed, I would think is a bit unusual. So it's, you know,
Yeah, I don't think VJ, like we shouldn't, I don't think we should, like
Mhm.
share the results and release the report without the
Sure.
additional investigation on Parker's side. I think we need to be able to explain the reason for the combos that failed. But I think given that the testing by Emil, like it passed for all the combos, I think it seems like it's low risk in the sense that it might be something setup slash fixture related, or that like also like that was a dry mate test at a very high speed, 330 millimeters per second.
Yeah.
So I think um if it can pass also at a lower speed, I think it will still be acceptable.
Okay. So, okay, I guess Julia, basically what just trying to summarize what you said is like we still need Andy to run the test. It's just that we'll wait, yeah, have to have the test done, correct, before we share the findings to you.
Yeah.
Okay. Yeah, so I guess Andy, yeah, maybe if you can follow up with your team and see where that if it's like a few days, few weeks out, let's at least maybe if you can get a date from the team on, okay, roughly this is the date to test it. I think that we can go from there. Given that hopefully it's 2 to 3 days worth of testing. So
okay.
all right, thanks. Nick, any updates on your side?
Sure, the update I have is I've got the red cap source. We'll be able to make that change without an issue. And it's just, I'll just be changing our internal paperwork to reflect that internally, and we'll be able to deliver those on our normal lead times at any time.
Okay, so it looks like going forward you can start shipping with the updated colors.
You got it. Yep.
Yep. Okay. Okay. Sounds good. Thank you. All right. Julia.
Oh, sorry. I guess can we go back to Andy real quick on the
Sure.
dust caps also?
Oh, yes.
Uh, yeah, just updates on implementing the dust cap color change.
Yeah, like my paperwork is through on making the change. Um, I guess if you give me a couple minutes, I can see, and I think we're going to order some of the caps. I can see if they're in stock. That would be the only thing I wouldn't know, but otherwise we're planning on, uh, you know, we're planning on having that red cap on plug halves.
Okay, so basically like starting now, you're
I
if
think
you
like
have any.
I think like starting today. But I'll have to
Okay.
see if we actually have gotten the red caps in to our system, like if there's inventory.
Okay, got it.
That's I'm not sure, but I can check. And if I can't get it in this meeting, I can send you, or I'll put it in the minutes. All right, I'll
Yeah,
say
that's fine. That's fine.
if they're in stock or not.
Okay. All right. Okay, yeah. And then so I had a question for everyone that came up recently, which is if we have a chassis with BMQC on the chassis inlet and outlet, and then there's also manifolds in the rack with BMQC. I was wondering what is the recommended like flow rate slash differential pressure for filling the chassis. And the fill path is kind of like, you know, like from, you have a BMQC socket on the supply manifold that goes to the supply BMQC plug on the chassis, through the chassis, and then returns through a BMQC plug on the chassis to a BMQC socket on the return manifold. And I'm specifically asking this with respect to preventing seal washout.
I think it's a situation where you'd want to be careful in how you're filling it. So this would be, it's connected, and then it would be filled.
Right.
And it would be, while you're connecting it, it would have full flow available, like
E
8 liters per minute on the upstream connection side,
yeah, I think like
connecting to 0 PSI.
yeah, because the chassis would be empty. So
Fif-
there's
fif-
nothing.
Yeah, 50 PSI
Nothing.
on one side, 0 on the other, full flow potential available on one side, filling to something that has nothing in it, just air.
Right.
Well,
Yeah. Is that like okay, or like is it recommended to be lower? Like if you did it 55 PSI at 9 LPM, like full flow, is that gonna cause seal washout?
No, I guess in
Uh,
my opinion, Julie, I think it's okay. I mean, if everything's connected, I don't think that we'd be too worried about if you're controlling the flow rate and you're saying that we won't be over 8 or 9 LPM. I don't think that's going to cause a problem for us.
Oh, so if everything is oh, you're saying like if everything is connected though. Like if the plugs and sockets are connected, and then you are flowing like 9 up to 9 LPM, that should still be okay.
Yeah, if you're within the ratings, I don't think we're going to see. I guess it's just kind of a clarification of what you're.
But I
So
guess
because
it might not be, so let me back up. It might not be um I think there will be a differential, like when, because like the one side of it is an empty chassis, and then another side of it would be like a flow loop with a like a pump um to flow induce like flow and whatnot. So actually I think when you connect it, like the chassis side will actually um will actually be like, say like potentially like zero, like just um like 0 PSI, no fluid on that side. I think um the the like pump side you'll see potentially like um some amount of like different like pressure on that side, and then as soon as you connect it, then there will be some flow through.
Yep, for sure. It just kind of comes. It's yeah, it's highly dependent on the conditions of the flow that's available to it, right? Like so, and I think Andy has started to mention too. Like if you had an inlet manifold, then you had that at like unlimited flow available at 50 psi, then you would get probably some very large initial flow rates through the system, and that's what we're worried about. That's what we're calling an open loop connect, and we think that should be avoided. But if you're controlling the flow rate, or using a pump cart, maybe a lower differential pressure, that would probably help. So I guess it's um,
Yeah, I think the flow rate is controlled. Like it should be controlled like to say 9 LPM or lower. Um
Yeah, it would be harsh if you said, well, we've got 9 liters per minute. We've got 50 on one side, 0 on the other. One side's got liquid, one side's got air, and we're going to just do a connection. That is a harsh connection.
Julia, just one question. What is the temperature also? Because that will also be important factor.
I'm not sure on temperature. I'd have to check. I think, yeah, I'm not sure. I have to check.
Because it will make this condition more harsh, like Andy mentioned, with the temperature.
So like in general though, like the BMQC spec, the seal washout is tested at 55 psi differential, 50 degrees fluid, 50 degrees C fluid temperature. Is there like is there a certain flow rate this was tested at, or um I wasn't sure looking back at the test specs.
I'd say it's a little bit unknown, at least for how we tested it.
Yeah, I think it was uncontrolled. I think we maybe tried to measure what the peak flow rate was during the test. I'm not sure that it wasn't specified or consistent across sites. I thought that we tried to capture it.
So would like I guess like would BMQC like would it still pass, you'd say, like at 55 psi, 50 degrees C and 9 LPM?
It could have been less than 9 LPM. Could have been more.
Yeah, I mean, I can see what I can find. I guess, I mean, we did the test, and I think everybody, passed it. It's just that it's just not best practice to do that. If it did happen, would it survive? I mean, likely. That's why we did the test as a durability test, but recommending that to somebody is something that I'd have a little hesitation for that, I guess.
Well, what would be the best practice
Well,
for?
here's a statement in the so UQD is they're working on a like a version 2 or kind of a
Right.
revision of the spec. And here's the statement they have. For guidance on use in an open loop scenario. So what we're talking about here is kind of like an open loop scenario. In an open loop scenario, such as during filling or draining a server, contact the QD supplier for guidance. In an open loop scenario, extreme pressure drop and line velocity across a UQD valve set can induce seal washout event. As such, fill and drain practices should follow a progressive introduction to flow and pressure within ratings. So that's the statement. So there's it has been kind of identified that this is an area that caution should be practiced in how this is done. Someone could end up with something that's at like maximum harshness for the design in terms of, full differentials or opening, with one side not even to liquid but wide open to air. As a supplier on our end, I would say, don't do that. Try to do something more gradual. At least, especially if it's just filled with air completely.
Yeah, I saw the UQD V2 spec also. And I saw that they noted for like fill drain to check with the suppliers for directly for recommendations, which is why I wanted to check with you guys on what is the recommendation for BMQC. Um,
Yeah, I mean, my recommendation, there's an O-ring worst case test, but if you're filling it saying, yeah, I'm just going to fill it like that. My recommendation is don't do that.
So like in general, try to have more like of a like in general, like, you know, don't do 55 PSI, 9 LPM. Try to have or a 50C, like try to have like a more gradual flow and pressure uh increase.
Yeah, that would be my recommendation.
Right, that's best practices. You know, in general, we advise that, you know, they shouldn't be connected under pressure, at least, especially at that first connection. When
Or
we're,
you generally advise not to connect under pressure, under differential pressure.
yeah, that's probably a good distinction, I guess, because we are, you know, we are connecting, making pressurized connections, and we have done some testing to verify that the, you know, the O-rings don't wash out. But yeah, but it's yeah, exactly, connecting under for full differential pressure is yeah, it's not advised.
Yeah, I don't think you have that name.
Okay. And I guess if you do have to connect under some differential pressure um or flow, is there a limit recommendation? Like don't go over half the rated pressure or something?
It probably would need some additional exploration in order to, you know, come up with a solid statement. You know, you know, if you had high differential but lower flow, that's definitely a better situation.
Oh, wait, say that again.
Well,
Higher.
if you said there's no way I can not have this high differential, having lower flow is definitely an improvement.
Oh, I see.
They kind of both have an influence.
Yeah, gotcha. Okay.
I mean, right. The worst case is high flow and high differential. You're better off with low flow and high differential. I mean, the very best is low differential, low flow. And then in between there is low flow with high differential or high flow with low differential. You know, those are your middle ground.
What's better, like low flow with high differential or high flow with low differential? Like in terms of seal washout, is the flow
Probably low differential. Like, you know, we did lots of connects at 50 PSI on both sides with no flow, and there's kind of no problem. So that would be no flow, no differential. I guess that's back to that.
so between like flow rate and differential pressure, the differential pressure is usually a bigger contributor to seal washout.
Thinking this over.
Yeah, I think that's true. I mean, especially if we're like, so let's just say that we're going to stay within radians either way. I think if you connected with a low differential pressure and we're at like the rated flow, it's likely that it would be durable to that, I would think. And if you're specifically talking about like, you know, you're trying to talk about the filling procedure, right, Julia?
Yeah, yeah.
So you can control your equipment's a little bit different than it would be in the data center with like, you know, a ton of flow available. Because that differential pressure is what drives the flow.
Mhm.
In that case, and if there's nothing to add restriction, then the flow rates can get really high. But if you're if you're filling it with a pump and you somehow have some sort of a control mechanism where you can control the flows and pressures to get something that's not quite as aggressive as a full differential, then you know that helps.
Okay, gotcha. Yeah, thanks for the feedback on that. I might circle back if there's further questions on this. Uh, and then I'm mainly asking this also, yeah, because there was a case of seeing a seal washout during yeah, in like a fill fixture. But yeah, I'll circle back if more questions on that. And then the last reminder is just um let's start working on the summary report and have a draft what you can fill out by the next meeting. I know some of the Parker testing will still be outstanding. And then we're still aiming to try to complete towards the end of the month. Yeah.
Okay.
I do have to hop to another meeting, but thanks everyone.
Thank you.
Thank you.
Thanks, everyone. Yeah.